Hello everyone. In this video, we will have introduction to conic sections, parabola, ellipse, hyperbola. These curves are known as conic sections because these curves can be obtained by cutting a cone in different fashion. These curves come under engineering curves like cycloid, hypocycloid, epicycloid, spiral, helix. All these are engineering curves, and conic sections are also called engineering curves because these conic sections have many engineering applications. To draw these curves, we should know the basic mathematics involved behind these curves, and it is also very interesting to know the mathematics behind these curves. Before going to discuss these conic sections, that is parabola, ellipse, and hyperbola, we will discuss circle first. We know what is a circle. It is a set of infinite points, set or locus of infinite points, which are at fixed distance from fixed point. This fixed point is the center of circle, and fixed distance is radius. You go anywhere on this path or curve or locus, we will have a fixed distance. This is the constraint behind getting this circle. What is circle? It is a locus of infinite points at fixed distance from fixed point. Like this, conic sections should have some constraint. What is that constraint? Let us try to understand. In conic sections, we have fixed vertical line. What we call that fixed vertical line, it is a directrix, and we have the axis of curve. It may be parabola, ellipse, hyperbola, and on this axis we have focus. Focus is a fixed point, and directrix is a fixed vertical line. In circle, we had fixed point as center and fixed distance as radius. Here we have fixed point, focus, and fixed vertical line, which we call directrix. Now let us draw one curve. If I draw this curve, and if I take any point on this curve, say P, if I join this point with focus F, and if I drop a perpendicular from this point on this fixed vertical line, that is directrix, then I get two distances. Let us call this point as M. Now, if I take the ratio of two distances, that is PF upon PM, what I have taken, the ratio of distance of point from fixed point to the distance of point from fixed line. Now let us take another point, say P dash. If I again join this point with focus and drop a perpendicular from this point on directrix, let's say this new point is M dash. Now let's take again ratio of this point, the ratio of two distances of this point, that is P dash F upon P dash M dash. P dash M dash. Like this, we have infinite points on these curves, and every time if you take this ratio, then we will get this ratio constant. We get this ratio constant, and if we get this ratio 1, then we get parabola. And if ratio of two distances, that is distance of a point from fixed point to distance of point from fixed line, if we get that constant less than 1, then in that case we get ellipse. We get some another curve ellipse. We get some another curve ellipse. For that, this is the vertex. Vertex is the point common to curve as well as axis. We get ellipse. Here also the ratio of two distances is always constant. The ratio of two distances is always constant. And this constant is known as eccentricity. What is this constant? This constant is E, eccentricity. Eccentricity. And if this constant is greater than 1, then that time we get hyperbola. 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 Hyperbola will be somewhat like this. This is hyperbola. This one ellipse, and this one is parabola. Parabola. Now with this background we can define conic sections in general. It may be parabola, ellipse or hyperbola. And how to define conic section? It is the path traced out by a point moving in a plane such that the ratio of its distance from fixed point to its distance from fixed line is always constant. Depending upon the constant value of that ratio, we get different curves. If that constant is 1, we get parabola. If that constant is less than 1, then we get ellipse. And if that constant is greater than 1, we get hyperbola. Once again, what is the definition of conic section? It is the path traced out by a point moving in a plane such that the ratio of its distance from fixed point to its distance from fixed line is always constant. And that constant value is 1 for parabola, less than 1 for ellipse, and greater than 1 for hyperbola. That's it for this video. Thanks for watching. We will meet again in the next video with some problem. Till then, goodbye.